Hello again. Here is our video on the independent study packet, Calc 3. If the material in this video is going too fast or too slow, remember you have the ability to pause, rewind, or fast forward. Part 1, the directions say to factor completely. In order to factor completely, I would recommend circling both groups. Now, if you look carefully, both groups have an x plus 1 squared in common, and both groups have an x minus 3 in common. Right now, we are talking about GCF factoring. When we're doing GCF factoring, remember this tip: take out the lower of the exponents. So if you listened carefully, I said that each group has x plus 1 squared in common. Squared is the lower of the exponents. So in number 1, the GCF is x plus 1 squared times x minus 3. So we're going to take out an x plus 1 squared, and we're going to take out an x minus 3 from both groups. If we do that, we are left with two things. In our first group, we're left with x plus 1 to the first. In our second group, we're left with 4, and we're left with x minus 3 to the first. Now, we need to simplify what's left over. We have x plus 1 squared times x minus 3 times x plus 1 plus 4x minus 12 if we distribute. That gives us our final answer: x plus 1 squared times x minus 3 times 5x minus 11. Let's skip to number 3. First, circle the two groups. Now, look to see what the two groups have in common. Each group has x plus 3 cubed in common, and both groups have x minus 1 to the first in common. The GCF is x plus 3 cubed times x minus 1. So now we need to take out the GCF. We are taking out x plus 3 cubed times x minus 1 from both groups. And if we do that, we should be left with two things. In the first group, we're left with x plus 3 to the first, minus. In the second group, we're left with a 2, and we're left with x minus 1. Now, we should simplify what's left over. To do that, make sure we distribute the negative 2. We will get x plus 3 cubed times x minus 1 times x plus 3 minus a 2x minus plus 2. Finally, we'll combine our like terms. X plus 3 cubed times x minus 1 times negative x plus 5. We could accept this as a final answer. That negative x plus 5 does look a little bit weird to me, so we could also take out a negative 1. If we take out a negative 1, we'll have negative x plus 3 cubed times x minus 1. Remember, we're taking the negative out of this right here, so if we take the negative out, we'll be left with x minus 5. So here is another appropriate answer. Okay, time to skip down to number 5. We should go ahead and circle the two groups. We can see that each group has an x to the 1/2 power in common. Therefore, the GCF is x to the 1/2. You can remember as our tip to take out the lower of the exponents. So now we're going to take out an x to the 1/2. If we do that, we're left with two things. From the first group, we're left with x to the 4/2 And from the second group, we're left with a 1. If you don't have confidence in yourself, you can always check your work as you're going along. Same base, add exponents. We'll have x, and if we add the exponents, that would be 5/2. And finally, x to the 1/2 times 1 is x to the 1/2. So far we're doing it right. But now we have to simplify. We have x to the 1/2 times x squared minus 1. Alright, x to the 1/2 is the square root of x, and x squared minus 1 can be factored further into x plus 1, x minus 1. Remember that the directions say to rewrite without fractional exponents. Okay, now we will skip to number 7. To factor completely, circle the two groups. Note that negative 1/2 is the lower of the exponents. So each group has x plus 2 to the negative 1/2 in common. The GCF is x plus 2 to the negative 1/2. So we're going to take out x plus 2 to the negative 1/2. And when we do that, we're going to be left with two things. First of all, in the first group, we're going to be left with 2 times x plus 2 to the 2/2 power. In the second group, we're left with a 5. Now, if you're not confident in your factoring, then you can always check yourself as you go along, and you can check by distributing. So here's our check. Remember, same base, add the exponents. So if we distribute, we have 2 times x plus 2, that's the same base. Add the exponents, negative 1/2 plus 2/2 is 1/2. Continue to distribute, and we'll have 5 times x plus 2 to the negative 1/2. That's what we started with, so that means that we're doing it right. Okay, now we have to simplify what's left over. So we have x plus 2 to the negative 1/2, and we have 2 times x plus 2 to the first plus 5. Distribute the 2. We got x plus 2 to the negative 1/2 times 2x plus 4 plus 5. That means we have x plus 2 to the negative 1/2 times 2x plus 9. Now the directions say to rewrite without negative exponents or fractional exponents. If it helps, you can put over 1. Just remember, the x plus 2, we need to move that into the denominator and make the exponent positive. So if we do that, we will get 1 all over x plus 2 to the positive 1/2 times 2x plus 9 over 1. That means our final answer is 2x plus 9 divided by the square root of x plus 2. Okay, so I will start you off with number 9. We are going to factor this expression right here. So I would recommend circling the two groups. We can see that each group has an x squared plus 6 to the negative 1/2 in common. The GCF is x squared plus 6 to the negative 1/2. So we're going to take out x squared plus 6 to the negative 1/2. If we do that, we're going to be left with two things. X squared plus 6 to the 6/2 power plus 1. Check yourself if you're not feeling confident. Just remember, same base, that means add the exponents. So if we distribute, we'll have x squared plus 6. Negative 1/2 plus 6/2 is 5/2. And if we continue to distribute, 1 times x squared plus 6 to the negative 1/2 is x squared plus 6 to the negative 1/2. So that's checked. From here, we would have to simplify what's left over and rewrite so that we do not have a negative fractional exponent. See if you can continue with this problem to obtain this. Okay, part 2. The directions say simplify the expression using two methods. A, adding or subtracting the fractions, and B, factoring completely. Number 1, part A. It might help if we write the square root of x plus 3 divided by 1. Now, to add these two fractions, we need a least common denominator. In this case, the least common denominator is the square root of x plus 3. So therefore, multiply the first fraction by the square root of x plus 3 divided by the square root of x plus 3. Remember that the square root of x plus 3 times the square root of x plus 3 is just equal to x plus 3. So when we multiply, we get x plus 3 divided by root x plus 3. We're adding that to 1 divided by root x plus 3. Now that we have a common denominator, we can bring the fraction together, and after we combine like terms in the numerator, we get our final answer, x plus 4 divided by the square root of x plus 3. We can leave our answer like that. Part B. Now we will simplify by factoring completely. First, let's rewrite this expression so that it has fractional exponents. We have x plus 3 to the 1/2 power plus x plus 3 to the negative 1/2 power. It might help to circle both groups. We see that the groups have x plus 3 to the negative 1/2 in common. So the GCF is x plus 3 to the negative 1/2. Therefore, we need to take out x plus 3 to the negative 1/2. If we do that, we'll be left with two things. We'll be left with x plus 3 to the 2/2 plus 1. And now we can simplify what's left over. We have x plus 3 to the negative 1/2 times x plus 3 to the first plus 1. It might help to put denominators. Now, since we have x plus 3 to the negative 1/2, remember to throw the x plus 3 in the denominator and make the exponent positive. Therefore, we have x plus 4 in the numerator and x plus 3 to the 1/2 in the denominator. That is equal to x plus 4 divided by the square root of x plus 3. So using that example, please complete number 2, 3, and 4. Now, when you get to number 4, you can simplify the expression to get 2 root 1 minus x squared. You're going to have to use your properties of exponents in order to obtain this. So just as a little reminder, remember that a to the n times a to the m is equal to a to the n plus m. Same base, add the exponents. In the case of this problem, I think we need a to the n divided by a to the m equals. Since we have same base, subtract the exponents. We'll get a to the n minus m. Part 3. Rationalize the denominator. The directions say remove the sum or difference from the denominator by multiplying the numerator and denominator by the conjugate of the denominator. We will do 1, 2, and 3. For number 1, we have x divided by 1 minus the square root of x squared plus 1. So in order to rationalize the denominator, we need to multiply the numerator and the denominator by the conjugate, which is 1 plus the square root of x squared plus 1. In multiplying the denominator, we can use the first-last technique. So in the denominator, we will get 1 minus the quantity x squared plus 1. In the numerator, we could distribute the x to get x plus x times radical x squared plus 1. We should make sure we remember that root x squared plus 1 times root x squared plus 1 is equal to x squared plus 1. Now in the denominator we can distribute this negative. We will get x plus x times the square root of x squared plus 1 divided by 1 minus x squared minus 1. Now in the denominator we have like terms that we can combine. So we have x plus x times radical x squared plus 1 divided by negative x squared. To simplify this fraction, it might be helpful to break the fraction apart. We have x divided by negative x squared plus x times radical x squared plus 1 divided by negative x squared. So now we're seeing some cancellation. X goes into x squared x times. Same thing over here, x goes into x squared x times. So therefore, positive 1 divided by negative x is negative 1 over x. And the same thing over here, positive 1 divided by negative x will end up with negative the square root of x squared plus 1 divided by x. Since we have a common denominator, we can bring the fractions together. Our final answer, negative 1 minus the square root of x squared plus 1 divided by x. For number 2, we're going to rationalize 1 divided by 1 minus the cosine of x. In order to do that, we got to multiply the numerator and denominator by the conjugate, which is 1 plus cosine of x. Now to get our denominator, we can use our first last multiplying technique. That'll give us 1 minus cosine squared of x. In the numerator, we can multiply to get 1 plus cosine of x. Okay, remember from our trig unit that 1 minus cosine squared of x is equal to sine squared of x. So therefore our final answer is 1 plus cosine of x divided by sine squared of x. For number 3, we're going to rationalize 2 divided by x plus the square root of x squared plus 1. And in order to do that, we got to multiply the numerator and the denominator by the conjugate, which is x minus the square root of x squared plus 1. To multiply the denominator, we can use the first last technique. In doing so, we'll get x squared minus the quantity x squared plus 1. Remember that root x squared plus 1 times root x squared plus 1 is equal to x squared plus 1. In the numerator, if we distribute the 2, we'll get 2x minus 2 root x squared plus 1. Okay, in the denominator we can distribute the negative. We will get 2x minus 2 root x squared plus 1 divided by x squared minus x squared minus 1. In the denominator we have like terms that we can combine. So we get 2x minus 2 root x squared plus 1 divided by negative 1. If it helps, we can always break the fraction apart. And now simplify. 2x divided by negative 1 is negative 2x. Right here, negative divided by negative will get us positive. So we'll end up with a plus 2 root x squared plus 1. Okay, so please use these examples to complete 4, 5, and 6. So congratulations, this is the end of our independent study packet. I hope that these algebraic techniques help you in your calculus course.